Hello and welcome to today's class. For this class, we'll be considering physics, but on a topic called Newton's law of motion. Let's discuss a very important topic in physics, a fundamental, very important topic in physics called Newton's law of motion. When it comes to physics, Newton's law of motion is very, very important and fundamental, which as a science student, you need to know. All right, let's discuss Newton's law of motion. Newton's law of motion was discovered by Sir Isaac Newton in the year 1642 to 1727. Newton's law of motion was discovered by Sir Isaac Newton. All right, aside this, there are about 3 laws of motion. We have the first law of motion called law of inertia. We have the second law of motion called law of acceleration. And we have the third law of motion called the law of interaction. Let's discuss the 3 laws of motions. Number 1 there, we have the law of inertia. Number 2 there, we have the law of acceleration. Finally, number 3 there, we have the law of interaction. These are the 3 distinct laws of motion that we have. Number 1 is called the law of inertia. Number 2 is called the law of acceleration. And number 3 is called the law of interaction. All right, let's discuss this law one after the other. Let's start with the first one there called the law of inertia. Let's start with the law of inertia. By definition, the law of inertia, also called the first law of motion, states that a body will continue in its state of rest or its uniform motion except it is being acted upon by an external force. So I'm saying that Newton's first law of motion, also called law of inertia, states that a body will continue in its state of rest or its uniform motion except it is being acted upon by an external force. That's like the law for the first law of motion. So from the first law of motion, you're hearing the word inertia, inertia, inertia. What does inertia means? What does inertia means by definition? Inertia is simply the tendency of an object at rest to remain at rest, and the tendency of an object in motion to remain in motion. So the tendency of something to remain at rest and the tendency of an object in motion to remain in motion is simply what there is called inertia. So I'm saying that inertia is the tendency of an object at rest to remain at rest and the tendency of an object in motion to remain in motion. That's like definition for inertia. Aside discussing about the Newton's first law of motion, let's talk about the second law of motion, number 2, called law of acceleration. Let us call this second law of motion called the law of acceleration. What does the Newton's second law of motion, also called law of acceleration, states? It states that the rate of change of momentum of a body is directly proportional to the applied force that takes place in the direction of that force. That's like the law of acceleration, also called the second law of motion, which states that the rate of change of momentum of a body is directly proportional to the applied force that takes place in the direction of the force. All right, when it comes to Newton's second law of motion, also called law of acceleration, there's a mathematical expression for it. So mathematically, mathematically, I'm saying that force is proportional to what? Rate of change of momentum. Rate of change of what? Momentum all over time. Now listen, please. When you hear the word rate, rate is a time bounding word, right? So when you hear the word rate in physics, it means that thing is changing with respect to time. So I'm hearing that the rate of change of momentum, it means changing momentum over time. So now look up, please. From my law, observe the law, second law of motion. I said that the rate of change of momentum is directly proportional to what? To the applied force that takes place in the direction of the force. So look up, please. In that law, there are two things there: force and rate of change of momentum. From the law, which one comes first? From what I stated now, we observe that the rate of change of momentum is directly proportional to what? To the force. So from the definition I gave you, this is how the mathematical expression should be. Why is it that I'm having force before rate of change? From my definition of law of motion, I said the rate of change of momentum is in proportion to what? To the applied force. So observe that rate of change of momentum comes first before force. Why is it that mathematically I'm having force before rate of change of momentum? The reason is that there is not the idea there is that a force must be applied before there is a change in momentum. So a force must actually come first before there's what? There's a rate of change of momentum of a body. So that's why mathematically I'm having force before rate of change of momentum, as you can see here. From here now, let's break this down. In mathematics, if I have proportionality sign, how do I take off proportionality sign? I will introduce an equal to and a constant. So I'm having that force F is equal to K, a constant, and what? Change in momentum M. Sorry, momentum is P, as we said in last class, all over time. Last class, we established the concept of momentum and impulse. And we said momentum is the product of what? Mass of a moving body and the velocity with which the body moves. So I've dropped the link to momentum and impulse in this video. So momentum, we said last class, momentum is P, right? So represented by P. So I'm having change of momentum P over time here. At this point here, what next? My next task is to assume let K constant to be equal to 1. So assume that K is unity. By unity, I mean 1. So I assume K to be 1, or you call it assume K to be unity. So it means whenever you hear the word unity in science, it means something is equal to 1. So if I let K to be 1, it means that force F is equal to K is 1 into change in momentum over time. From here, multiply by 1 by this, I'll have that force F is equal to change in momentum over time. But last class again, when we discussed momentum and impulse, I said that the difference between momentum and impulse is that momentum is mass and velocity, while impulse is what? We said impulse, J, is what? Change in momentum. And we said the mathematical expression for change in momentum is what? That's mv minus mu. We said this last class when we discussed momentum and impulse. So the idea is now, the idea here is that watch our previous class on momentum and impulse to further give you better understanding of this concept here, please. All right, so I'm saying that change in momentum means mv minus mu. So I'm having change in momentum here. So I'm having that force F is equal to change in momentum is what? Mv minus mu. So by having what? Mv minus mu as change in momentum, then over time. At this point here, what next? My next task now is that observe that M and M are occurring here. So I'll factorize M out. So by having a force F is equal to bring out M out into V minus U all over T. I'm having this here. So at this point here, what my next task? Observe from here that I'm having something here. Observe clearly from here. I can say that force F is equal to, I'll separate these two. It means that we're having mass times, or perhaps mass into V minus U all over T. Is T correct? Mass times V minus U over T. I'm having this one here over time. Just separate it in this way. It's still mathematically correct. From here now, what's my next task? What's my next task from here? My next task here is that I'll be having a force F. Sorry, before that, observe that I'm having V minus U over T. There's a kind of parameter that expresses V minus U over T. That's what the acceleration. Recall that from here. Recall that acceleration A is equal to what? The change in velocity all over time. When we say change velocity, what do we mean? We mean what? V minus U all over what? All over this T. So I'm saying this expression, this one here. So replace this one here with A at this point here. I'll have that force F is equal to mass. So force is equal to mass times, we said replace this one here with what? Acceleration. I mean A. So from here, force is equal to mass times acceleration. This formula was got from Newton's second law of motion, a very, very important formula in physics called Newton's law of acceleration, right? As you can see, it's in front of you here. So that the derivation for force is equal to mass times acceleration. All right, at this point here, let's discuss this third law of motion called law of inertia. Number 3 there, law of interaction, please. Let's discuss the law of interaction. Law of interaction states that for every action, there's an equal and opposite reaction. That's like the law to the third law of motion, as you can see. I've stated it now. So we'll be using the idea of basically of law of acceleration and law of interaction to solve further problems on conservation of linear momentum and collision and all the likes. So looking at conservation of linear momentum in our next class, and aside that, we'll be looking at collision and what have you. If you found this class helpful, do well to like, leave a comment and share. I just created a WhatsApp group to further communicate with us. If you're interested in joining our WhatsApp group, simply check the description of this video. I'll drop a link to our WhatsApp group there. See you in our next class.